So guys, hello and welcome to the second part of my video series for the virtual machine. The next topic we are going to talk about is the memory, are the memory and the registers. So the LC3 architecture has 65,536 memory locations. Just for write it down, the number looks like this, and it's 2 power 16. So we can say 2 power 16. Result is this number. And how does this look into our C code? So it's defined here. We define the number of memory max with this 1 shifted to the left by 16 locations. So that means we have this 1 and it's shifted to the left by 16 locations. So 1, and then the shift would look like this: 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, the number would like this. We have a lot of zeros, and the most significant bit at this place, at the 16th by 17th place, gives us the number 65,536. Yeah, basically it's the same as when you write int memory max ist gleich 526. But in our C code we are going to use something like this a lot, because we are doing so much low-level operations, bit operations, and it's just to get familiar with this. So, and in the next line we are going to define an array which has so much space as the number here. Okay, it's basically the same as we say int with the name array with 65,536 locations. That this would mean the same as this. Okay, just for the better understanding. So, and basically that's it. We have our memory declared with 65,536 locations, and each of this location is an address, and each of these addresses containing 16-bit values. And now maybe you are going to ask yourself, why exactly 16-bit values? Each instruction in the LC3 architecture has exactly 16 bits. So that means in each place of the memory we have one instruction, or maybe we have a value, because the value are stored in our registers. This is the next topic I want to go into, the registers. Each register is storing a value of 16 bits. That means our all values, maybe the instruction itself or the values we are going to use in the instruction, are 16-bit. And this is very useful to, say, okay, we have our memory with these locations, and in each location we have an instruction or a value used by our program. So that's it. Now let's take a look into the mentioned registers. Here we have an enumeration of exactly 10 registers. And what is a register? What's the purpose of the registers? So a program workflow is loading values from the memory into registers, calculating values with some logical or arithmetical operations, and then storing the result into another register. And after finishing the instruction, we are storing the final result out of our register back in the memory. So that's it. And here we have 8 different registers for the general purpose for storing values or storing the result of operations, and you can store what you want into these registers, and they are indicated by the bits from the instructions. And to indicate 10 different registers, we need exactly 3 bits. So when we are finishing this is 0, 1, 1, here 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So like this, we are indicating the 8. I think I made some mistake now. Okay, with this we are indicating our 8 general purpose registers. This register is for the program counter. It's a very special register. So now maybe you're going to ask yourself, what is the program counter? How we are using the program counter? Why is this a special register? And I think that's very easy. Okay, as the name is saying, it's a counter. It's a counter for the instructions of our program. Okay, let's imagine we have written a program in assembly language, and this program is exactly 10 lines. Okay, so at this place we have our first instruction, and the program counter is counting to exactly this instruction. We are performing the instruction, and after finishing the instruction we are going to incrementing the value in the program counter register by 1. When we're going to read the next instruction, we read the value out of the program counter register, go into the memory and read the instruction out of the memory at this position given by the program counter. And because we have incremented this by 1, we are going to this line. We are performing the instruction, we're incrementing the program counter. So then we are going back to our basic step, read the value out of the program counter, go to the memory at the position of this value, and reading the instruction, and that would be the next one, and so on till our program is finished. This is the purpose of the program counter. And how does this look in the code? Here we have a while loop, and we are reading out of the memory. We are reading the value of the program counter register, what's stored inside, and we are incrementing this by 1, and then we read at the memory at this given position, and the result is our instruction. So that's basically the purpose of our different registers. We just have one more register. It's the condition register, and it's used for the flags. You can see here, but I go into this in another video.